Hey guys, how's it going? Welcome back to the next episode of solving problem statements in Java. Now, in this episode, we will be solving the eighth problem statement, and the problem statement is finding minimum cost spanning tree of a given corrected undirected graph using Kruskal's algorithm. Use union find algorithms in your program. Now, just a reminder for you guys, if you guys don't know or you are watching this series and this as your first episode, let me remind you guys all the source code, source code for all the programs I have uploaded in my GitHub repository. The link is given in the description below. I've uploaded the programs with the all the necessary comments as well so that you guys can understand how it all works together. Now with that said, let's get started. Now before we start, I just want to mention you guys one thing. Let me tell you how this entire video is segregated into. First of all, I will show you guys the output, and after that I will show you guys the source code and explain you in an abstract fashion, okay, in a brief manner how the program is being written. Now I will try to explain you the functions, only the function names, what they do, and after that, once I show you the output and explain you briefly how the program is being written, after that we will take up an example and we'll try to trace that example using the program. So with that said, let's get started. Okay, yeah, coming to the output section, I am currently in that directory, and let me invoke the file. Okay, just Java source because it's only one file. Enter. Okay, currently it's compiling, and what it is asking is enter the number of vertices of the graph. We'll take a small graph, that is number of vertices are 4, and after that it will ask me to enter the weighted matrix, and here is the weighted matrix that we'll be using not just to show the output but to explain you the tracing as well. So this is the example that we'll be taking up. Now here I want you guys to understand, here we have taken 99 as to assume it as infinity, so that you can even take it as even 999 or any other value. So 99, we have pre-assumed that if it's a 99, we are thinking it of as an infinity. Now let me just hit enter. Boom, we get the solution directly. Here the minimum cost edges are 1 comma 2. So 1 comma 2 is 10, 3 comma 1 is 10, 4 comma 1 is 10. So and the minimum cost spanning tree is 30. Now let's come to the program section. Just again. So this is our program. Okay, you can find the same program in the GitHub repository as well. So one file, one class, okay, and a bunch of functions. Let's see what those are. And this is our parent vertex. Now before I abstractly explain, here on the right side I'll be writing all the stuff, like for example, as you can see, I'm tracing out. So this is the function. On the right side I'll be writing all this stuff using my hands on my tab so that you guys can understand. And we have one global array, that's parent. On the right side I have presumed it as P. As you can see, I have declared a P array. That means it's a parent array here. Another next function, total number of functions that we are using in our program is 4. So main function, obviously we are invoking it. Here we have a scanner class, the Kruskal class, that is the file name as the class name as is the same. So after this we have a variable n to store the number of vertices, and two-dimensional array to store the weighted matrix, that is the graph. As you can see, I have declared on the right side. So there's the same graph that we have been using. Instead of typing the instead of drawing 99 there, I have drawn the infinity symbol. So please pardon my handwriting. Okay. After that I am printing out enter the number of vertices of the graph message. After that I am scanning the n, that's number of vertices. After that I am scanning the weighted matrix in the two-dimensional array A. After that we are invoking the solve function using our Kruskal object. So let's see what our solve function does. Solve function, to explain in a brief, guys, what it does is it does all the hard work in our program. Basically, it does all the heavy lifting. So it has got Kruskal algorithm implemented within it. So it finds all the minimum edges, okay, and it finds the minimum cost of it and checks whether it is a spanning tree or not. So that's what all it does. And another two helper functions that I would call is, one is union. as of now time being, let's understand union function as given two parameters, two vertices I comma j. What it does is, based on ranking based technique, don't think of it as any like sci-fi. It's just a simple ranking technique that we'll use and to rank them in an appropriate fashion. So what it does, how it does, when it does, why it does, we'll look at it in a minute. After that, we have the last function, that is find. It takes one parameter m, which is presumed as a vertex. So m is a vertex here. So when you give find a particular, when you supply a particular number here, that is vertex, it basically tries to find its parent vertex of a given vertex m. So how it does, we'll come back to that again in a minute. So as we looked at our main function, the solve function is invoked with the double two-dimension array is being passed and the number of vertices are being passed. So let's look at the solve function and let's start tracing out. Okay. Now we come down, I have opened up the function, we have declared and initialized some variables, that is u, v, k, sum and minimum. Now what's sum? It stores the minimum cost of the entire spanning tree. Now we are using k as just a counter variable so that we can iterate through the entire graph once. It's just a counter variable and nothing else. What is u and v? We'll come back to that when they are being used. Okay. After that, we come inside the for loop. We check for this condition. Why we are using this for loop? Well, that's because to iterate through all the edges in the given matrices, we are using that. Okay. Now let's start tracing. K is less than n minus 1. So what's k? K is initially, as we are entering it for the first time, k is 0. So let me just write it here, 0. So please pardon my handwriting. Alright guys. So yeah, k is 0, 0 less than n minus 1. What is n? N is our number of vertices. That is 4. 4 minus 1, 3. Now we know 0 is less than 3. So we come inside the while loop and we initialize minimum as 99. So now instead of writing it as minimum, here on the right side I will just take it as m, so that it's easy for me to write it as well as for you guys to understand. We initialize minimum as 99 and after that we come inside the loops, that is I loop and the j loop. So we initialize I equal to 1 and we come inside the I loop, we initialize j equal to 1. Now we are both inside the while for loops. Inside the while for loops, we come to check the if condition, that is, let's check the first condition, a of I comma j. Now what is a of I comma j? Now that's a of 1 comma 1. Now that in our graph is exactly here. Now that's infinity. So let's see, a of I comma j is 99. 99 less than minimum. What is our minimum? 99. Now we know that 99 is equal to 99. So that condition turns out to be false. Now that condition doesn't satisfy. So we don't just check the next condition and the iteration is skipped. So now the j value is implemented. Let me just update the j value here. All right. Oh, oops. That's looking as z. All right. Now the j value has been updated. Sorry. Okay. J value is being updated. Now again, we check the conditions. Okay. Now a of I comma j, that means a of 1 comma 2. What it is? That's this one. That's 10. So let me just write it down here. A of 1 comma j is 10, a of 1 comma 2 is 10, a 10 is less than minimum. What is our minimum? That's 99. Now that condition satisfies because we know that 10 is less than 99. And now we check for the second condition, I not equal to j. Now what's our I? 1 not equal to 2, that's j. Now why are we checking that? Because any edge where I is a particular vertex, j is a particular vertex. Now when we select two vertices, that means we are selecting an edge. Now we don't want that particular edge to be a self loop. Let's say for example, if we take I equal to 1, j equal to 1, that means we are selecting a self loop which doesn't matter in a spanning tree, right? So that's the reason why we are not we are trying to avoid them. So that's why we don't want I and j value as the same. So here in this case both are not the same, so we come inside the if block and see what happens. We come inside the if block. Here we are updating the minimum value. So see, we update minimum value as a of I comma j. What's I and j? That is 1 comma 2. What's a of 1 comma 2? That's 10. So let me just update the 10 minimum value at the top section as well, so that we can use it for future reference. Okay, after that we are initializing two new variables, that is u comma v. Why we are doing that, I'll explain you guys in a minute. Let me just write it here at the top. U as I, that is 1, v as j, that is 2. Okay, now with that said, now this if block gets executed and again j value gets incremented. Now here's a little bit of tricky part because I'm not going to explain entire graph because it's just a simple technique that you guys need to understand. If you understand that, you will exactly understand what exactly is happening through the entire two for loops for the rest of the time they are executing. So I'll come back to them in, so don't worry, it's quite easy. Let me just update these. Now j becomes 3. Okay, now let me just tell you guys here itself. What's a of I comma j? I is 1, j is 3. That's 1 comma 3 is 20. 20 is less than 10? No. Skip the iteration. Now j becomes 4. Now what is a of 1 comma 4? 30. Is 30 less than minimum? What is minimum? 10. No, 30 is not less than 10. Again, skip. Now comes the tricky part. Here I is incremented. So let me just explain you once how that works. Okay, I gets incremented and j gets initialized again to 1. Okay, because now it indicates we are at the second row. So we now a of 2 comma 1 is selected. That's here. A of 2 comma 1 is 10. We check, we write it, let me write it down. A of 10, that's less than 10. Okay, 10 less than minimum. Now what's minimum? 10. So we know that 10 is equal to 10, so we don't need to update that value. Again, skip the iteration. Now this goes on and on until all the rows are gets executed. If you look at the entire graph, so as I said, the tricky part, here's the tricky part that you guys need to understand. Instead of me explaining through the entire matrix, it will be a lengthy job. So it's quite simple graph. You guys can understand it. So if you look at it, if you look at the entire graph, which is the most minimum value? That's 10. What this particular graph is doing is, which is the most minimum value in the graph, okay, and when its first occurrence is occurring. So here the most minimum value is 10. Okay, after that we have 10 values again repeated, but we are not selecting those as the minimum wedge. Why is that? It's because here first time we are selecting it and we are just keeping it as it is. And one more thing, here you can see we are using less than operator and not less than equal to, because we don't want to, because if we do, the first 1 comma 2 will be skipped and it may not get selected further. So yeah, now our minimum edge is 1 comma 2, that is u comma v. Now we this entire for loops get executed, it comes down, and here we are. Now we know the value of u, that's 1, we know the value of v, that's 2. Now what we are doing is, given the value of u, we are trying to find its parent vertex. Let's try to, now the find function is invoked. Okay, we come up, we try, here is the find function. Here in this case, let me explain you guys how it all works. Okay, let me just erase it. Okay, right. Sorry, let me not just erase it entirely, because let me explain you guys it one more time. Okay, here we are using the find of u, that is 1. So basically we are finding the parent vertex of 1. So it comes inside the find function. We initialize integer p as the m, that is parameter m we have given as m1 in this case. We come inside the next instruction, that is while loop. Okay, now here we are checking if parent of given p, that is parent of p, what is the p parent of p 1, if it's not equal to 0. Okay, what we are trying to do is, we are trying to update the value of p as the current parent value, that is 1. Now in this case, if you guys can see parent of 1, what's the parent of 1? As you guys can see here, it's nothing. That means it's equal to 0. Initially in Java, you might guys be knowing, it initializes every array as default value as 0, sometimes even as null. So initially it initializes as 0. So here in this case, while in this iteration, parent of first vertex is 0. Now that means the while loop doesn't get executed, so it comes outside the while loop, so it returns the p value itself, here in this case 1 itself. Now what's the parent of 1? It's 1 itself. So let me just erase this entire find function. Okay, now it comes outside. Okay, here value 1 is stored because parent of 1 is 1. Now if you look at the v, here parent function of v, here parent of 2 is nothing, so entire parent array is 0. So what it does is, even it selects parent of 2 as 2, sorry, not 22, it's 2. Yep, after that it comes down. Now let me just repeat what these two lines do is, given the select minimum edge, okay, this particular vertex, we try to find their parent vertex. Okay, here the parent vertex of 1 is 1, parent vertex of v is v. We store it in different integers, and after this we come inside this if condition to check if I not equal to j. Now what's I and j? That's 1 comma 2, the parent vertices of u comma v. Now if you guys might ask me, why are you checking that? That's because, let's consider an example where let me just draw it here. This is a vertex, this is b vertex, this is c vertex. Okay, here in this case, let's say this is our u, this is our v. Now on this b and c vertex, if we invoke the find function, it will return a as the parent vertex. Let's, the parent of u is a, the parent of v is a. Now we don't want that, because in spanning tree, here in this case, we are not considering as a cycle. Now we don't want, if given two vertices, their parent vertex are both are the same, that means they are forming a cycle. Now in spanning tree, we don't want that, so we are avoiding, and if it's a cycle, we are just skipping the iteration. Now here in this case, it's 1 and 2, so 1 not equal to 2, we come inside the if block. Now here we are invoking the union function with the given I comma j. Now please note that don't get confused with the I comma j here in the upper section. They are different. Once the for loops got executed, they both are removed from the memory, and again we are declaring fresh new variables. Okay, so here I comma j after outside the for loop indicate the parent vertices of u comma v. Now we are sending them as the parameters for union function. Let's see what union function does. Okay, as I've written in the description of the function in the comment section above, it uses a rank based technique to arrange two vertices parent in an appropriate fashion. Now what's an I here? Let's check. I equal to 1 and j equal to 2. Okay, is I less than j, that is 1 less than 2? Yes, we initialize as parent of 1 is 2. Okay, so that we know that parent of first vertex is second vertex. So let me just write it here. Parent of 1 is 2. Yep. So that's how basically in parent vertex we are writing down for any given vertex what is their parent vertex, so that it will help us to easily find out the minimum edge and the vertex next time. After the union function is done, it doesn't, if you look at it, it doesn't return any value, it just updates the parent array. After that we are printing out the current edge, that is u comma v, and that u comma v value, that is a of 1 comma 2, that's 10. Now so let me just show you where it's getting executed, that is 1 comma 2, that's 10. Now after that we are adding the whole sum, so that we at last we can show it to the user. The cost of minimum spanning tree is 10. Initially this is the first time that it is getting executed. Initially the sum we have initialized as 0, so 0 plus a of u comma v, that's 10, so 0 plus 10 is 10. Now after this we are incrementing k value, so it comes down and we are setting a of u comma v, that is a of 1 comma 2 as 99. Why we are doing that? That's because next time when again this comes out and checks the while loop condition and again it gets executed, we don't want the same edge to be selected again, so we are setting it as 99. Here in this case we have assumed, as I said before, as infinity, so that's the reason why we are keeping it as 99. We are setting it as 99. Now you might ask me, I understand we are setting a of u comma v as 99, but why a of v comma u? That's because initially we are using, if you look at the question, they have given as connected undirected graph. Now as we are using the undirected graph, if you look at the values here, a of 1 comma 2, is 10, a of 2 comma 1 is also 10. So that means as they don't have a direction, both the values at both the directions is the same. So any edge you select 1 comma 2 or 2 comma 1 is both the same. So we don't want that both the edges to be selected again. So let me just update it with the red color, so that we know that they have been updated. Let me just write it over here itself. They have been updated now. Okay. Now as we are still in the while loop, now the k value is turned to 1 because we have incremented it here. Okay. After it comes down, again it checks. Let me just write it entire thing once again. Okay. Now k value is 1. K less than n minus 1. What is n? Number of vertices. That's 4. 4 minus 1, 3. Yes, 1 is less than 3. It comes down. We are reinitializing the minimum value as 10. Okay, let me just update it here for reference to 99. That's infinity in our case. Again, the same old thing. Okay, so yeah, kind of fun, Again, we are setting I value as 1. Inside the I value, I loop, we are setting j value as 1. Again, we come down and we check for the if condition. If a of I comma j. Okay, we know that it's infinity, it doesn't get executed. So change it. So next j value becomes 2. A of 1 comma 2 is also infinity, change it. A of 1 comma 3 is 20, right? A of 1 comma 3 is 20, we select it. A of 1 comma 3 is 20, so let me just write it here. A of 1 comma 3, now that condition, let's just check it. A of 1 comma 3, what it is, that's 20. 20 less than 99, yes. Let's check the second condition, that is I of 1 I not equal to j. I not equal to j, that is 1 not equal to 3. So we know that 1 not equal to 3, it comes inside the if block, and we update the yum value as 20, right? So let me just go at the top and erase it, type it there, just update the value. So in this way it just finds the minimum value. So if you look at 20 is not the most minimum value. Okay, now after that the j value again gets incremented to 4. The I value is 30, it doesn't get updated, the minimum value doesn't get updated. It's because the minimum value is 20 and 30 is greater than 20. Now I value is incremented, it is in the second row. Now if you look at that, we don't have any value less than 20, and 2 comma 1 it was 10, but as we changed it to infinity, so it doesn't get selected now. It comes down to third row. Now as you can see, when, let me just show you guys so that you get a complete picture. Alright, no problem, I'll write it once again. When I is equal to 3 and j is equal to 1, it comes down. Okay, now in this case a of I comma j is 10. 10 is less than minimum. What's our minimum value? 20. And as always, now here you know I is not equal to j, that is 3 not equal to 1, so it gets, the entire conditions get true. We come inside the inside the if block. Now we update yum as 10. Boom. So let me just update it here as well again. That's 10. Okay. Again we select u as 3. Okay, let me just erase it here. U as 3. Okay. U as 3. Okay, yeah. U as 3. I was just checking if I have made any mistake. No. Yeah. U as 3, V as 1. Right? Yes. V as 1. Yum as 10. Now if you look at the graph, there is no other value than 10. So as we are using the less than operator, not less than equal to, so even if it's in the fourth row, it doesn't get selected. So now at this case, at this iteration, our most minimum edge is 3 comma 1. Again we come down, we find their parent vertex, the parent vertex of 3. Now if you look at the parent array, there is no parent vertex for 3. So what the value is found is 3. Now again for parent vertex for v, that is 1, the parent vertex, as we last iteration we have updated, the parent vertex is 2. Now here the parent vertex for 1 is 2. Let me just trace it out for you guys. What it does is find, I will just write f, find of 1. Okay, now you will get complete picture of how find function works. Okay, it comes down here, we initialize p as 1. We check while parent of 1 not equal to 0. Is parent of 1 not equal to 0? Yes, obviously parent of 1 is not equal to 0. The value is 2. So it comes down, we set p value as parent of p, that is parent of 1, that's 2. Again it goes for the parent, again it goes up and checks for the parent condition. Now as the p value is 2, we check parent of 2 not equal to 0. No, parent of 2 is equal to 0. So it comes outside the loop and the value returned here is 2. And that's exactly what I had written here. That is, the parent of 1 is 2, right? It comes down, again we check whether the current selected minimum edge and their parent vertices are not the same. They are not the same here in this case, that is 3 not equal to 2. It comes down, again it ranks them by the union ranking method. So let me just erase and show you guys in this particular example. Okay, so this is the last let me tell you one guys here, one note. This is the last iteration I'll be showing you guys, so that it will be not lengthy as well. If you guys have any kinds of doubt, let me know in the comment section below. If you guys didn't understand how a particular function works or anything like that, any kind of doubt with respect to this program, let me know in the comment section below. I'll try my best to help you out guys. Now with that said, let's see how union function works in this case. Let me just take u as, what's the I value here? That's 3. What's the 2 value? J value? That's sorry. What's the j value? That's 2. We go inside the union function. Okay, here a union function. I is less than j. Here I value is, this is our I value, this is our j value. Okay, now 3 is not less than 2, right? 3 is not less than 2, so parent of j, that is parent of 2, becomes 3. Parent of 2 becomes 3. Now let me just update it here. Parent of 2 becomes 3. Okay, now let's come down. It just ranks them, their parent vertex. We print that particular edge a of u comma v, that is 3 comma 1. Now let's see in our output whether we have got the right answer. Exactly, now we have got 3 comma 1 and its value is 10. Now we add that. Last time if you remember, that is the sum value was 10. Again u comma v, the value is 10. So the total value here in this case, 10 plus 10 is 20. Now the entire same thing happens. See, like for example, the entire thing, what I mean is the entire for while loop gets executed. It checks for k is less than -1, it gets executed. The for loop gets executed one more time until the for loop. Now this time here this gets infinity, so the only edge that we'll be selecting is 4 comma 1. It comes down, it finds the parent vertices. Now we know that their both parent vertices are not the same, so we don't form a cycle. Again it comes down, it prints the edges of 4 comma 1. Let's see if it is right. Yes, it is right. It writes it is right. After that, as the sum is already 20, e of u comma v, that is 4 comma 1 is 10. 20 plus 10 is 10. Sorry, 30. So again we are incrementing the k value. Now in this case the k value becomes 3. Now when I say in this case, that means when the selected vertex selected minimum edge is 4 comma 1 and not the 3 comma 1, that times when you increment k value becomes 3. So we come outside, again we check. Now as the k value is 3, n minus 1, that is 4 minus 1 is 3. 3 is not less than 3, so 3 is equal to 3. We break out the loop, we come outside the loop. What we do, one simple line is we print the cost of minimum spanning tree. That's 30 in our case. Did we get 30? Exactly, we got 30. Now this function finishes executing. Again we return to the main function. This function got completely executed. After that we are closing the scanner and boom. So that's it. That's how the 8th program works. If you have guys, let me just repeat you one more time. If you guys have any kinds of doubt, if you didn't understand how the find function works or union function works, okay, let me know in the comment section below. I will try my best to help you out guys. I will see you in the next video. Until then, have a good one.